Hello viewers, in today's session we are going to discuss a very important integral. So here we'll solve this integral from 0 to 1, and we have x square and 1 over x minus 1 raised to 1 by 4, right? So here we'll solve this integral by method of beta and gamma functions. So let us start. So let us first call this integral as I, right? And here we'll initially we'll make some simplifications. So here we have 0 to 1, we have x square, and we can take here the LCM, that is x and 1. So we have 1 minus x over x raised to 1 by 4 dx. So let us rewrite this integral as x square and distribute this power 1 over 4 to 1 minus x and x. So we have 1 minus x raised to 1 by 4. Here we have x raised to 1 by 4 dx. Now combining these two terms, we can now write 0 to 1 x square, we have 2 minus 1 over 4. So we can subtract the powers by using the rules of exponent, and here we have 1 minus x raised to 1 by 4 dx. So now we can rewrite this integral as 0 to 1, and we have x raised to, this is 4 times 2 is 8 minus 1 over 4, that is 7 by 4. So here we have 7 by 4 and 1 minus x raised to 1 by 4 dx, right? So now what we have done so far, we have expressed this integral like this, and now we'll convert this integral into a beta function. So now the beta function is defined as beta m comma n is given by this integral, that is 0 to 1, and we have say x raised to m minus 1, and here we have 1 minus x raised to n minus 1 dx, where m and n are greater than 0, right? So this integral is known as beta function, and here m and n are positive numbers. So we'll express this integral like this. So what we can write, we have 0 to 1 and we have x raised to 7 by 4, right? So now we can take m minus 1 as 7 by 4. So m is 7 by 4 plus 1. So this is 7 plus 4 over 4, that is 11 over 4, right? So we can here write 11 over 4 minus 1. So 11 over 4 minus 1 is 7 by 4, and similarly here we have 1 minus x raised to 1 by 4. So 1 by 4 can be equated to n minus 1. So we have n is equal to 1 by 4 plus 1. This is 1 plus 4 over 4, that is 5 by 4. So here we can write 5 by 4 minus 1. So now we have expressed this integral like this, and if we see the two integrals, we have m is equal to 11 by 4 and n is 5 by 4. So this integral is now equal to beta of m comma n. M is 11 by 4 and n is 5 by 4. So now to move further, what we will do, we'll convert beta function into gamma function through this relation, that is beta m comma n is given by gamma m, then gamma n divided by gamma of m plus n, right? So this expression is now equal to gamma of 11 by 4, then we have gamma of 5 by 4, and then we have gamma of 11 by 4 plus 5 by 4, right? Okay, so now we'll simplify these two terms, that is gamma of 11 by 4 and gamma of 5 by 4. So gamma of 11 by 4 can be written as gamma of 1 plus 7 by 4, and through this relation, that is gamma of n plus 1 is given by n times gamma of n, where n is some fraction. So here we have gamma of n plus 1. So n is 7 by 4. So gamma of n plus 1 can be written as n times gamma of n. So here we have 7 by 4 times gamma of 7 by 4. So now let us express gamma of 7 by 4 again with the help of this relation. So we have 7 by 4, we have gamma of 1 plus, here we can write 3 by 4, right? So 7 by 4 is 1 plus 3 by 4. So we have 7 by 4, and then again applying this result, we have 3 by 4, then gamma of 3 by 4, right? So gamma of 11 by 4 can be written as 7 over 4 times 3 by 4 times gamma of 3 by 4, and let us apply the same rule to gamma of 5 by 4. So here we can write 1 plus 1 by 4. So this is 1 by 4, and here we have gamma of 1 by 4, right? So now this integral I can be written as, here we have 7 by 4, 3 by 4, gamma of 3 by 4, right? Gamma of 11 by 4 is substituted here. Then gamma of 5 by 4, this is 1 by 4. Then we have gamma of 1 by 4. And in the denominator, we have gamma of 11 by 4 plus 5 by 4. So 11 by 4 plus 5 by 4 is 16 over 4, that is 4, right? So here we have gamma of 4. So now let us simplify this expression. So now gamma of 4 can be written as gamma of 3 plus 1, that is equal to 3 factorial, right? Because we know this relation gamma of n plus 1 is equal to n factorial when n is a positive integer, right? So 3 factorial is 3 times 2 times 1, that is 6. So now here we can write, this is 7 times 3 is 21, and 4 times 4 times 4 is 64, and then we have gamma of 3 by 4 and gamma of 1 by 4, and here gamma of 4 is 6. So now we can express this quantity by using Euler's reflection formula. So now Euler's reflection formula states that gamma of n times gamma of 1 minus n is given by pi divided by sine n pi, right? And we can now write gamma of 1 by 4 and gamma of 3 by 4 as gamma of 1 by 4, and here we have gamma of 1 minus 1 by 4, because 3 by 4 can be written as 1 minus 1 over 4. So here if we compare this one and this one, then the value of n is equal to 1 by 4, right? So this quantity is equal to pi divided by sine. N can be replaced by 1 by 4, so we have pi by 4, right? And sine pi by 4 is given by 1 over square root of 2, because this is sine 45 degrees. So this is now equal to pi times square root of 2. So now we can replace this expression by pi times square root of 2. So we have 21 over 64, and here we have pi root 2 over 6, right? So now we can cancel 21 and 6. The common factor is 3. So here we have 7, and here we have 2, right? So this is 7 pi root 2, and here 64 times 2 is 128, right? So here's the value of this integral. I is given by 7 pi square root of 2 over 128. So this is how, by making use of the concept of beta and gamma functions, which are also known as Euler's integral, we can find out the values of these type of integrals. Hello viewers, in today's session we are going to discuss another important and conceptual problem from integrals, right? So here in this class we are going to evaluate this integral from minus infinity to infinity e raised to 6 times t dt over 1 plus e raised to 2t raised to power 4, right? So let us start. Now see here, first we'll call this integral I, right? And we are going to solve this integral by method of beta and gamma functions, right? So first of all, we'll use the concept of substitution method. So let us first take or introduce a new variable, say u is equal to e raised to 2 times t. So we'll make this substitution here. U is equal to e raised to 2t. Let us differentiate u with respect to t. So we have du over dt is equal to e raised to 2t, because the derivative of e raised to 2t with respect to t is e raised to 2t, and by chain rule the derivative of 2t is simply 2, right? So e raised to 2 times t is replaced by u, so this is 2u, right? So now we can write dt is equal to du over 2 times u, right? Okay, so now let us change the limits accordingly. So here t varies from minus infinity to infinity, right? So when t tends to minus infinity, which is the lower limit, so then we have to find the value of u. So u tends to e raised to 2 times t, and t tends to minus infinity, so u tends to e raised to minus infinity, right? And e raised to minus infinity tends to 1 over e raised to infinity, and this is 1 over infinity, that is tending towards 0, right? So when t tends to minus infinity, then u tends to 0, and similar is the case with infinity, that is when t tends to infinity, u tends to e raised to infinity, and e raised to infinite tends to infinite, right? So our limits are now u is equal to 0 and u is equal to infinity, right? So now let us write this integral in terms of u. So I is now equal to integral from 0 to infinity e raised to 6 times t can be written as e raised to 2t, and here we can take the power 3, right? By rules of exponents, this is 3 times 2 6, so e raised to 2t is u, so we have u cube, right? So here we have u cube, and then for dt we can write du over 2 times of u, and in the denominator we have 1 plus u raised to 4. So now let us simplify it further. We can take half outside the integral. We have 0 to infinity, and here this u get cancelled, and we are left with only u square, and in the denominator we have 1 plus u raised to 4, right? And here we have du. So now we have converted, or we have reduced this integral into this form by making this substitution, u is equal to e raised to 2t, and now we'll express this integral in terms of beta function, right? Because see, the beta function is defined as beta m comma n is given by the integral 0 to infinity, and if we have the variable say x, then we have x raised to m minus 1, and here we have 1 plus x raised to m plus n, right? Where m and n both are greater than 0. So now here we have the integral in terms of u. So we can now compare these two integrals, right? So here we have x raised to m minus 1. Here we have the variable u. So we can form two equations here in m and n. So m minus 1 can be equated to 2, and m plus n can be taken as 4, right? So that we can find out the values of m and n. So m minus 1 is equal to 2. So we have m is equal to 2 plus 1, that is 3. And taking m is equal to 3 in this equation, we have 3 plus n equal to 4. So n is 4 minus 3, that is 1, right? So the value of n is 1 and m is 3. So now we can write this integral as 0 to infinity, and u square can be written as m minus 1. M is 3, so we have 3 minus 1, and here we have 1 plus u raised to 4, and 4 can be written as m plus n. M is 3, n is 1, so here we have 3 plus 1, right? So now this integral can be written as half, and this form is now equal to beta of m comma n, and m is 3. Here we have 2. So here we have beta function, that is beta m comma n. M is 3, n is equal to 1, right? So now we have to find the value of this beta function, right? So to find out the value of this beta function, we can express, or we can use a relation connecting the beta function with gamma function, and the relation goes like this: beta m comma n is gamma m, then we have gamma n and gamma of m plus n, right? So here we have half. Beta 3 comma 1 is given by gamma of 3, then we have gamma of 1, and here we have gamma of 3 plus 1, right? So this is half, and here we have gamma of 3, gamma of 1, and in the denominator we have gamma of 4, right? So now we can use this important relation, that is gamma n plus 1 is given by n factorial. So here we have half, gamma of 3 is 2 factorial, gamma of 1 is simply 1, or here we can write gamma of 4 as 3 factorial. So now we have half. 2 factorial is simply 2, and this is 1, and 3 factorial is 6, right? So 2 and 2 get cancelled, so here we have 1 over 6. So the value of this integral I is given by 1 over 6, right? So this is how, by making use of this important substitution and using the concept of beta and gamma functions, we can evaluate these kind of integrals.